A right-tailed hypothesis test about a population proportion. Suppose historically 42% of all Stat 205 students have made an A or a B. With recent changes, I would like to know if the percentage has increased. A random sample of 400 grades in Stat 205 is collected. Among these, there are 178 A's or B's. Using a 0.05 level of significance, does this indicate that the changes have resulted in a higher proportion of Stat 205 students making A's or B's? The parameter P represents the proportion of all students taking Stat 205 who make an A or a B in the course. The null hypothesis H sub 0 is that P equals 0.42. This is the historical value of 42%. H sub A states P is greater than 0.42. This is what I want to know if the data supports. Decision rule. If the p-value is less than or equal to 0.05, the level of significance, then the decision is to reject the null hypothesis H sub 0. Otherwise, fail to reject H naught. Sampling distribution validity. A random sample of Stat 205 students were selected and grades were categorized. Success was making an A or a B. N times P is 400 times 0.42, the value of P from the null hypothesis, and that equals 168, which is at least 10 successes expected. N times Q is 400 times 1 minus 0.42, or 0.58, which equals 232, and that also is at least 10, so the failures expected is also at least 10. So it is valid. The test statistic. The sample proportion minus the value of P from the null over the square root of P times Q over N. The 0.445 comes from 178 out of 400. So 178 divided by 400 is 0.445 minus 0.42 divided by the square root of 0.42 times 0.58 divided by 400. That equals 1.01 for the observed value of your z-score. The p-value. The probability z is larger than 1.01 is 1 minus the 0.8438 from the table, which yields 0.1562. The decision. I decide to fail to reject the null hypothesis because 0.1562 is not less than the level of significance 0.05. In summary, using a 0.05 level, there is not significant evidence to conclude the proportion of all students taking Stat 205 who make an A or a B in the course now is more than 0.42, or the 42% historical figure. Note this is an example of what is called a right-tailed test. Why? Values in the extreme right tail of the normal distribution, large numbered z-scores that are positive, even bigger than 1.01, like 2.0, 2.5, 3.0, 3.5, okay, those support HA. A type 1 error consists of concluding that the alternative hypothesis is true when in fact the null is really true. So our alternative is that P is larger than 0.42. In this example, a type 1 error would be concluding the proportion of all students taking Stat 205 who make an A or a B is more than 0.42, when the truth is that only 0.42 or perhaps even less of all students taking Stat 205 make an A or a B. A type 2 error, on the other hand, consists of concluding that the null hypothesis is true when in fact the alternative hypothesis is actually true. In this example, a type 2 error would be concluding that the proportion of all students taking STAT 205 who make an A or a B is 0.42 or perhaps even less, when the truth is that more than 0.42 of all students taking STAT 205 make an A or a B.